Lesson 6-5, Graphing Linear Equations, and in this lesson you learn to graph a line given any linear equation. Why is it important? Because you can graph linear equations to show trends in fields like health and physical science. Let's take a look at this example in earth science. Salome was flying from New York to Spain to be an exchange student for the spring quarter. After climbing to cruising level, the pilot announced that they were at an altitude of 13,700 meters and the outside temperature was about negative 76 degrees Celsius. You may think that since you get closer to the sun as you get farther from the earth, you might get warmer as altitude increases. However, as altitude increases, the air gets thinner and colder. Okay? So the air temperature above Earth on a day when the temperature at ground level is 15 degrees Celsius can be calculated by using the formula A plus 150T equals 2,250, where A is the altitude in meters and T is the temperature in degrees Celsius. So suppose you wanted to graph the equation A plus 150T equals 2,250. So in chapter 5, you learned that you could graph a linear equation by finding and then graphing several ordered pairs that satisfy the equation. Okay, so using the x and y intercepts is a convenient way to find ordered pairs to graph a linear equation. In A plus 150T equals 2,250, these can be called uh, the A-intercept and the T-intercept. So to be able to find the A-intercept, okay, that simply means that T is equal to 0. So you have the equation A plus 150T equals 2,250, okay. So the A-intercept is when T is equal to 0. So A plus 150 times 0 equals 2,250. And the value of A would be 2,250. Okay, so that is the point where the line intersects the or intersects the A-axis. Okay, let's find the T-intercept. T-intercept with again for this particular equation is that when A is equal to 0, so we equate A to 0, 150T equals 2,250. We divide both sides by 150, we end up with T equals 15. So the T-intercept in this case is 15, okay? And that would be our Y-intercept, okay? So to be able to graph 2,250 and 0 and 0, 15, the ordered pairs for the intercepts, okay? This is how you graph them. So this is 0 and 15 and 2,250 and 0. Okay, so after graphing the ordered pairs for the intercepts, draw a line representing the equation by connecting the points. Thus you can graph a line if you know 2 points on that line. Okay, let's use the equation to confirm the pilot's announcement that the temperature was negative 76 degrees Celsius at 13,700 meters in altitude. Okay, and then we go back to the original equation. A plus 150T equals 2,250. We substitute A for 13,700 because that's what the pilot said. They were cruising at 13,700 and a temperature of negative 76 degrees. So A would be 13,700 plus 150T equals 2,250. And we simply solve for T at this point. Subtract 13,700 to both sides and divide both sides by 150. The temperature is around negative 76.33 degrees Celsius. So the pilot was correct in saying that the outside temperature was about negative 76 degrees Celsius. Okay? You can also graph a line if you know its slope and point on a line. The forms of linear equations you have learned in this chapter can help you find the slope and point on a line. Okay? So, In example number 1, we will try to graph the equation by using the point slope form, and let's proceed. Graph y minus 1 equals 3 times the quantity x plus 2. So the equation is in point slope form, and the slope is 3. Okay, so the slope for this equation is 3. Okay, because remember, point slope form is y minus y sub 1 is equal to the slope times the quantity x minus x sub 1, where m represents your slope. So in this case, our slope is 3, and the point of a line is negative 2 and 1. Remember, why is it 1? Because that's your y sub 1, and then why is it negative 2? Because this is x minus negative 2, if we follow this particular point slope form. Okay, so you have x negative 2 and y is equal to positive 1. Okay, do not be confused on this, because you will get the wrong point every time if you are. So we want to graph the point first, negative 2, 1. Remember that the slope represents a change in y and x. So let's graph negative 2, 1 first. Okay, and negative 2 and 1 is right there. So we point the point there, right there. Oopsie. Oh, never mind. Let's do my point. There, red point. Negative 2 and 1 is right there. Okay? So we remember that the slope represents change in y and x, which simply means this. Okay? So if your slope is 3, it means you have 3 over 1 change in y over change in x. Okay? Or simply rise over run. Okay? So using the slope, we can now find the other point. So if the slope is 3 over 1 and our run is 1, that means we start from the point that we plotted, negative 2, 1, and we run 1 time to the right, because the run is 1, and from there we rise 3 times up, 1, 2, 3, and put a point there. And now you can now connect those 2 points. Okay, there you go. Extend that one, and that is now, okay, the line with an equation of y minus 1 equals 3 times the quantity x plus 2, and that's exactly what we did here. So from the point negative 2, 1, you can move up 3 and write 1. Okay, draw a dot. You can repeat the process to find another point in the graph. Draw the same connecting points. Okay, if you want to repeat that process, you can do the same thing. Okay, run 1 time to the right, go up 3 times. If you notice, it'll be the same thing. So if I use another point right there, and my run will be to the right, and 3 times up, which will be my rise, you know, it will still fall on the same line. Okay, and if we check our answer, check negative 1, 4 to make sure that it satisfies the equation. So we substitute that to our point slope form. Negative 1, y minus 1 equals 3 times the quantity x plus 2. And then substitute 4 and negative 1. 4 minus 1, is it equal to 3 times negative 1 plus 2 in parentheses? And we know that it is. So our answer checks out. Okay? Now you can also use slope intercept form to help you graph an equation. For example, if you have, let me go back here. Okay, so if we want to graph 3/4 x plus 1/2 y equals 4, okay, so remember slope intercept form is y is equal to mx plus b, where m is your slope, okay, and b is your y-intercept. Okay, so we want to put it in this form: y equals mx plus b. You have 3/4 x plus 1/2 y equals 4. First, we want to solve the equation to find slope-intercept 4. We form 3/4 x plus 1/2 y equals 4, just copying the equation. Okay, then we subtract both sides by negative 3/4 x, okay, because we want to isolate y. So subtracting both sides by negative 3/4 x, we end up with negative 3/4 x plus 4, and then we simply multiply both sides by 2 to get rid of 1/2, to undo 1/2. So you end up with negative 3/2 plus 8, multiplying both sides by 2. Okay, now it is in slope-intercept form. Okay, and this tells us that the slope is negative 3/2 and the y-intercept is 8. So we want to graph the y-intercept, then use a slope to find another point on the line. Then after that, draw the line. So let's do that right now. So first we need to graph the y-intercept, which is 8. Okay. So we are, sorry about that. We want to graph the y-intercept, which is 8. So we graph the y-intercept, which is 8, right there. Okay. Well, actually, I already made an animation for that. Here you go. That's your, oops, that's the line, sorry. Well, okay, so the y-intercept is 8 right there. Okay, and then since our slope is negative 3/2, it simply means that uh, if it's negative 3/2, so that means this is your rise, and that is your run. Negative 3 is your rise, and 2 is your run, or it is the same thing as positive 3 as your rise, and negative 2 as your run. Okay, so let's do negative 3 over 2, which means a rise of negative 3, a run of positive 2. If we do that, since it's a rise of negative 3, we go down 3. 1, 2, 3. Okay, and a run of 2. 1, 2. Okay, and that's our point. So that means, okay, our line is not that, but let me correct that thing then. Okay, let me take out that line because that's not right. I'm going to draw another line, and that line would be this line right over here. Okay, let me fix it right there, and that's our line. Okay, so that is the line of the equation 3/4 x plus 1/2 y equals 4 using the slope-intercept form. Okay, and if you notice, this is our negative 3 rise and this is our positive 2 run. Alright, and in this case, be sure to check the second point to make sure it satisfies the original equation. So create another point and make sure it satisfies the original equation. Okay? Before we look at the example number 3, you frequently need to rewrite equations before you can determine the best way to graph them. So we have this equation 4/5 times the quantity 2x minus y equals 6x plus 2/5 y minus 10. So we want to rewrite this equation so we can find out how to graph this equation. So first things first, simplify the equation. Remember, an expression is in simplest form when there are no parentheses and there are no like terms. Okay, so we need to simplify both sides of the equation or the two expressions. Okay, so first thing we need to do is copy the problem and then multiply both sides by 5 to eliminate our fractions. Okay, so if you multiply both sides by 5, we now have 4 times the quantity 2x minus y equals 30x plus 2y minus 50. Remember, you need to distribute 5 to both of the expressions. Okay, and then simplify it further by using the distributive property. This becomes 4x minus y minus 4y, okay, is equal to 30x plus 2y minus 50. Okay, and then we add negative 8x and 4y to each side. We are now doing multiple steps because I'm sure by now you are proficient in solving equations. So we do multiple steps. We add negative 8x, which gets rid of our 8x, and we add 4y to both sides, which undoes 4y, negative 4y on the left side. Okay, and then after that we simply, okay, add 50 to both sides. Okay, add 50 to each side, and then from there, okay, we divide each side by 2 to simplify the equation further. So we end up with 25 equals 11x plus 3y. And using the reflexive property of equality, this now becomes standard form. 11x plus 3y equals 25. Okay, so you now have the standard form of the equation. 11x plus 3y equals 25. The equation is in standard form. You can now choose several methods to graph this equation. The first method is ordered pairs, by using ordered pairs. Okay, so by using ordered pairs, okay, if x is equal to 2 and y is equal to 1, okay, if y is equal to 1, then what's going to happen is if x, and another point that we're going to use, if x is equal to negative 1, y equal to 12. Okay, you can use any points you wish. Okay, but these are just the two points. These 2 points are just for as an example. Okay, and if we, okay, graph 2, 1 and negative 1, 12, you end up with this particular line right here. Okay, negative 1, 12 and 2, 1. That's one way of graphing it. Again, using ordered pairs. That means what we do here is we simply represent x with 2. After representing x with 2, we solve for y. And then we choose another point for x, in this case negative 1, and then we solve for y. And there you have your 2 ordered pairs. Connect those 2 ordered pairs with a straight line, you've graphed your equation. The other method is by using intercepts. And intercepts, we want to find where they both intercept the x-axis and the y-axis. So to be able to find their x-intercept, to be able to find your y-intercept, x should be equal to 0. So if we equate x equal to 0, this is 11 times 0 times 3, y equals 25, and you solve for y, that will be y equals 25 over 3. And to be able to find our x-intercept, y should be equal to 0. So if y is equal to 0, this is 11x plus 3 times 0 equals 25. And solve for x equals 25 over 11. And then graph your intercepts, and there you have it. We have the same line. And the last form that we're going to talk about is by using the slope-intercept form. That means we need to convert this into y equals mx plus b. So we copy the equation, and then we solve for y. So we subtract 11x to both sides, 11x plus 25, and divide both sides by 3. You have negative 11 thirds x plus 25 over 3. Okay, first we graph our y-intercept in slope-intercept form. That's the first step. We always graph our y-intercept first. Okay, that's our negative 25 over 3. And then we use our slope, rise over run, negative 11 over 3. Okay, so positive 3, negative 11. So you have a positive run of 3, 1, 2, 3, and a negative rise of negative 11. Connect those 2 points. There you have your line. Same line. Okay, and notice that the result is the same regardless of the method you choose. Okay, choose the method that you feel will be the easiest for you. Okay, the only tip that I can give you on slope-intercept form is this. Again, I told you this already. If you're using slope-intercept form, you need to graph the y-intercept first and then use the slope to find the other point. Okay? All right, let's go to the last example. Before going to the last example, okay, the secret word for this particular lesson will be rules. Secret word will be rules, R-U-L-E-S. So, and it is often helpful to make a sketch of the graph of an equation when you are trying to observe patterns and make predictions. Okay, let's take a look at this example and see how that works. The mule deer likes to feed upon bitterbrush plant, which is native to the dry regions of western North America. The diameter of each bitterbrush twig is related to the length of the twig by the function L equals 1.25 plus 8.983D, where L is the length in inches of the twig and D is the diameter in inches. And D is greater than or equal to 0.1. Okay? So we want to graph the function, name the independent and dependent variables, describe the relationship between a twig's diameter and length, and letter C, what would the length of a twig if its diameter is 0.5 of an inch. Looking at that formula, okay, we know that D is the independent variable. Why? Because it's saying right here, in this problem right here, the diameter of each bitterbrush twig is related to the length of the twig by the function. So that means the length is dependent on the diameter of the twig. Okay, so D is the independent variable, L is the dependent variable. Since D must be a non-negative value, it may be easier to choose two values of D and find corresponding value of L to graph. Okay, a calculator might be helpful, so let's do that. So again, let's do our let statement. Let D be equal to 0.1. Why 0.1? Because we want to make it greater than or equal to 0.1. Okay, and L, if D is equal to 0.1, will give us a value of 2.1483 using a calculator. And let's find another point, that D be equal to 1. If D is equal to 1, substitute the value. Okay, we end up with L is equal to 10.233. Now we have 2 points. Okay, we can graph. Okay, 0.1 and 2.1483, and 1 and 10.233. Okay, and then we draw them on a line and connect those 2 points, and that's our graph. Okay, and letter B, what it's asking is, describe the relationship between the twig's diameter and the length. As the diameter of the twig increases, the length of the twig increases. There is a direct relationship between the diameter of the twig and the length of the twig. And letter C, it's asking what would be the length of a twig if its diameter is 0.5 of an inch. So we simply substitute 0.5 to the equation. And then we have 5.7415. So a 0.5 inch diameter twig is about 5.74 inches long. And if you notice this point right here, which is 0.5 and 5.74, will be on that line, and our answer checks out. Okay, and that's the end of our lesson. Thank you for watching.